All right. I don't want to hear any complaints. Because that, to me, everything's just peachy. So we're in this great, fun content talking about grasses. My remote in. So we go back, we're talking about lateral growth and above ground stems that handle lateral growth. What are the two ways that plants can, turfgrass plants can?
Excuse me, Dr. Cruz.
Yeah.
Your microphone is really low. I don't know if it's only for me. It's very hard for me to hear you.
Just a minute, I can probably turn the settings on and up as soon as the system that controls all this.
Did you overhead right there?
Yeah. Like the old stock, old Elmo type thing. Well, that Elmo was transparency, so.
Yeah.
No, that was over projection. Yeah, it's like a little more. It's a digital camera, a document camera. Huh. You can turn the. It's now you can do transparency.
Yes. I wonder if like kids growing up now still have like the like transparency. No, they're probably also made out of this one.
So much so that I saw it with my kids were watching some of the Netflix or whatever showed one of them, and I'm like, what's that? So it's made it in the popular culture that they've not existed. Can you guys still hear me on Zoom?
I can, yeah.
Okay, I apologize. We're fighting a little bit of technical difficulty here. You guys can see what I'm talking about, but nobody here can see what I'm talking about. And so I'm trying to get this booted back up so that we can actually talk about something. So what are, I was in the middle of asking, what are the, now the slide came up, but we have two above ground means basically for lateral growth, right? We've got the stolons and the daughter plants on bunch type plants, right? Bunch type plants will spread laterally very slowly because these intravaginal stems grow out right next to the mother plant. And then we've got stolons, which are above ground. And what's unique about stolons, or what distinguishes stolons from rhizomes primarily? Chlorophyll. So both of them are going to grow laterally through the soil. They both are a stem with nodes, where the rhizome will be sort of cream or tan in color, and the stolon will be green with chlorophyll. So, you know, and that can matter, I guess, in some cases, just because it can help you, even if it's a little bit difficult to tell whether it's above ground or below ground. If it's got chlorophyll in it, you can tell that it's a stolon.
Tillers? Is that
Tillers, yeah. A tiller is this, literally just as the plant is growing from the initial single cotyledon, or monocotyledon cotyledon, as it gets additional leaves on it, there'll be another stem basically that breaks out and grows right next to the daughter plant that breaks right out next to the mother plant.
Yeah, like I have lemongrass. I think they spread like it.
Yeah. Rhizomes, very similar to stolons. They do store carbohydrates. They're below ground. They contribute dramatically to sod strength. Because they are below ground, grasses that have rhizomes will be protected from temperature extremes a little bit more, so they can have a little bit better chance of winter survival in cold temperatures. That being below the soil also contributes to wear tolerance. So we see grasses like Kentucky bluegrass, which is rhizomatous, Bermuda grass that has stolons and rhizomes, both of them being used in things with high wear type situations like athletic sports. Now, the bluegrass, Kentucky bluegrass, that rhizome structure adds not only some wear tolerance and stability to that profile for footing, that rhizome structure also allows for recovery, because if you've got this network of rhizomes underneath the soil and you do get some wear, then you've got nodes under there that can contribute new leaves and fill into the voids, where if you were planted to 100% of something like perennial ryegrass, which is often planted together with Kentucky bluegrass, because it's a bunch type grass, what happens when the plant gets damaged, the crown or core of the plant gets damaged? Huh? Die. Yeah, it dies. So if a bunch type grass, if that the crown of the plant gets damaged through foot traffic or something like that, then it will die. And so we wouldn't have any bait, because it's a bunch type, we wouldn't have any means of it growing back in and recovering like we do with something like Kentucky bluegrass with the rhizomes. Rhizome structure, which I'm not going to test you on, so it's there for your benefit if you want to look at it. Stolons, we've talked a lot about this so far, about the fact that these, grow, this is St. Augustine grass, and the stolons grow laterally across the surface of the soil compared to the rhizomes of some of the other grasses which grow underneath. It's an old enough picture that I know it's not. Roots, I'm going to try to skip through some of this a little bit because it's probably background. Roots do three main functions, right? Provide storage for carbohydrates for the plants. They anchor the plant into the soil, which also contributes to soil stabilization, right? And they serve to bring water and nutrients up from the soil into the plant. Doesn't mean that they're not important, because it doesn't seem like there's a heck of a lot that goes on there really in the grand scheme of things. But if I've seen anything over the years, I've seen so many cases. I was actually, this is back probably 2011, 2012. The individual who was taking care of Florida Field came to me and he's like, I happened to stop by. I said, how are things going? This is right, actually about this time of year. First, second week of August, and maybe we were about a month out from the first game. And I said, how are things going? He said, he said, fine, it looks fine. He said, but they're just not getting the clippings off of it that I think I should. Not growing, the field's not growing the way that I expected to grow. And so, well, let's go take a look at it. We go up to Florida Field, walk out there, absolutely beautiful. The field is pristine on the top. Took a soil sampler, profile sampler with me, stuck it in the ground, and the entire root zone was about this big. The rest of the roots that were there were black and brown, dark brown. They were stunted and like dying back. The entire field above looked beautiful, but it had basically no root zone. Now, there's a number of things that can cause that, but the thing that I guess I've always wanted to try to emphasize is, and I've seen it, where there's so much focus put on the canopy of a turfgrass system and how it looks, that people, turfgrass managers, homeowners, often lose sight of what's going on below the ground. I think if it looks fine on top, that everything's going to be okay, but so much of that plant's health depends on that root system being healthy, that it's really important to keep that in mind and always to be checking on it on some level, whether it's just simply reaching down. I mean, that at that point you could reach on the Florida Field and just pull grass out of the ground. And had they tried to play on it without trying, it was disease. They had they call root rot and Pythia root rot in there. So they hit it with a bunch of fungicide and really got it to start rooting down before they start playing on it. But had they had not caught that before they started playing on it, there would have been very little soil stability, very little traction. Probably could have had the potential to cause some injury because of that lack of stability from a footing standpoint. Because as athletes are, it doesn't matter if you're talking about athletes as horses or people, anything that has a heavy reliance on that surface being firm and consistent in terms of their footing, if they lose that firm consistency and that tension or torsion strength that takes to tear it out, that becomes either unreliable or unpredictable. It really increases the risk of injury to the lower extremities, because they either get hyperextensions or twisted ankles or whatever else. It can cause a lot of ligament injuries and things like that. So having that be stable and consistent is really important. Two types of roots. They get the similar primary roots that come from the seedling when it germinates. Their lifespan is usually less than a year, and then you've got the secondary roots that develop from the crowns and the lateral stems. They begin forming pretty soon after the first leaf emerges, and typically they will live as long as that shoot survives that they support. Now that's something to think about and kind of keep in mind. If we lose the shoot that is associated with that root node, right? So that where the node is, we've got shoots coming off of that, and we've got roots going down from it that are feeding back into that stem, whether it could be a rhizome, it could be a stolon, it could be the crown of the plant. If we lose the shoot associated with that root from that node, we're probably going to lose the roots that are associated with that shoot as well. So where that occurs, not only does it take the leaf tissue off, it also is going to come at the expense of the plant sloughing off its roots that were associated with it. Not now, as that plant progresses, it'll, because of the hormones being released, it'll produce new roots and shoots. But that comes at an expense from a carbohydrate reserve standpoint. So anything that, any stress that we put the plants under that causes them to lose carbohydrate production in the form of its leaf tissue, it's going to try to recover, but that takes carbohydrates. So when we think about plants that are growing in stressful conditions, whether it's temperature stress, light stress, could be shade, things that cause the plants to be less efficient than they could be otherwise, you can see how taking a plant that might just survive, when you put a little bit extra stress on it, it can cause it to start to fail. So you have a turfgrass system that's in shade. If there's a little bit of wear on it, it could be just that extra amount of stress on that carbohydrate production system that causes it to fail there, versus an area where it's able to get just enough light and sort of meet its needs because it's not being put under that additional production stress. Okay. I will refer to this probably more than you care to hear about, because so much of how we manage turfgrass systems depends on the environmental conditions they're growing in and the temperature time of year. All right. Top of the thing here are cool season grasses, going from winter, late fall or early, late fall going into winter. I guess that's actually probably more like first year winter. Okay. Into spring, summer, fall, and then back into early winter. All right. And the same is happening down below, where we start in the winter with the warm season grasses, go through the middle of the summer. And as we get into late summer and early fall, we see this transition in terms of both the vegetative growth and the root growth associated with those times of years. Now, what do you think is driving this primarily? Primarily temperature. Okay, there's more to it because light comes into play as well. We can see the light come into play, particularly with warm season grasses, because we look at warm season grasses, and as we go further south in Florida, we don't see a dramatic temperature shift from winter to summer. But we will see this change in growth because we see a different amount of light that's coming into the plants.
Is it more air temperature or soil temperature?
So
About-
more, so the question was whether it's more air temperature or soil temperature, and it's both. Both can come into play. Soil temperature tends to drive most of the change that we see. And soil temperature will, soil temperature is going to be following air temperature. As you see, air temperatures drop, soil temperatures start to drop. But the only exception to that I would say, particularly with the warm season grasses, is if we have a hard frost where it gets down to, in Gainesville, 18, 19 degrees might be a hard frost for us. But if we get a hard frost for a few hours, we will lose the canopy because the grass can't handle, warm season grasses can't handle it, and they'll go dormant, at least for a little bit. The leaf tissue that's there will burn off, basically. If we don't have any more like really cold temperatures or extended cold temperatures, they'll leaf back out. So it's not that they've gone entirely dormant, it's basically just the leaf tissue burned off because of the cold temperature. You don't see that impact the cool season grasses as much. Frosts don't really impact the cool season grasses a lot. One other thing about this that I want you to take note of is if you look at, it's easy to imagine that at any one point here in the spring, we could find an amount of temperature and light that is very similar or nearly exact as a point in the fall. Okay. But what you won't see is that these two amounts of growth be the same. At any one temperature and light combination, we'll see more growth in the spring than we will in the fall. Now, when we look at fertility programs for turf grasses, we usually, particularly with warm season grasses, will not recommend fertilizing right in the early spring as they're coming out of dormancy. The plants are basically programmed to use the carbohydrate reserves that they have in place, and they will come out of dormancy really aggressively growing and not really needing any nitrogen or other fertilization in those early days or weeks, and really not, it could put them under additional stress. It's really not beneficial in any sort of way. So that flush there, here we see in warm season or cool season grasses, that flush being exhibited with more growth than what we would see in the fall. Why do you think with cool season grasses we see this dip right here in the summer? So we think back, have we talked about, maybe we haven't yet. The adaptable range, I think it's up in our next section, the adaptable range for these grasses in terms of temperature is around 75 or 65 or 75 degrees to around 80 degrees. Somewhere, don't quote me on that because I think it's coming up in the next few slides, where these are like 80 to 90. So what's happening here is the temperatures get high enough that it starts to suppress the growth. They go into stress. Now, if you spend time in the Midwest, you'll see like that picture that I showed you in the on Wednesday, where that athletic field was dormant on the outside, but that area over the steam tunnel was green. That was the middle of summer where the warm season grasses were really growing aggressively, and the cool season grasses were dormant because it was so hot. So that's what we're seeing here as it relates to the relationship between these two things. Okay. Hello? The inflorescence on plants, the flowers, when they go into flower production, it is a process that consumes carbohydrate reserves. It typically will go into flower production under some sort of stress. We'll see it in sometimes the temperature stress with Bermuda grass. Drought type stress can sometimes trigger flowering in some of these grasses. It does result in death of the shoot the flower comes out of. Can be difficult to mow. An example is like Bahia grass. Any of you have had the pleasure of mowing Bahia grass when it's in full seed head production? You know, when the seed heads are, 14 or 16 inches tall, it's easy to miss them or have them basically get pushed under a mower and get skipped by the mower and then pop back up right after you've gone past them. Not such a problem with rotary mowers as it is with reel mowers. If you're mowing with a reel mower, you're almost certainly going to push all the seed heads over and have them pop up behind you because the rollers will push them down, reels go across the top, and you don't have any chance of cutting them. They can disrupt play. An example is Poa annua on putting greens. Poa annua is a prolific seed head producer. There was research that showed that one Poa annua plant can produce somewhere around like 1,300 seeds in a growing season or something like that. It's a really, really prolific seed head producer. And it does tend to be unsightly. One of the things that some of the Bermuda grasses, particularly the more common type Bermuda grasses that are used in athletic fields, have as a frustration by end users is that they can produce a lot of seed heads. Celebration is an example of one that produces a lot of seed heads at different times of the year. Celebration Bermuda grass has this beautiful, dark green sort of growth, but when it goes into seed head production, the canopy almost turns gray because there's so many seed heads out there. Stages of inflorescence development, it starts with the maturation of the plant, induction initiations, and then inflorescence formation. Juvenile plants are insensitive to the conditions that promote tillering. Like I said, some of the different stresses and things that will cause the plant to start producing flowers. Low temperature in some plants can cause flower production. Cool season grasses have a vernalization requirement that they receive temperatures of as low as maybe 32 degrees over the winter while they're sitting in the soil to cause them to produce flowers the next spring. And that basically creates, they produce their seed the next spring and then they come back and harvest it if necessary, if they're doing it for seed production. Short days can substitute for vernalization in some grasses like perennial ryegrass and Colonial bentgrass. Warm season grasses, on the other hand, don't have a vernalization requirement, but we do see warm season grasses respond to some environmental stresses.
How long does the
I don't. So the question was, how long does the vernalization need to be? And I know that, like for some actual flowering plants, that vernalization can be very specific. I don't know that there's any specific number that it needs to be. It's what's that?
It's like probably more specific to the plant.
Yeah, and I don't know that it's anything that we study vernalization requirements on some of the like flowering bulbs and things like that to be able to force flowering, artificially basically. I don't know that it's ever an issue that we have to try to make sure that we've met it. I don't know that it is. Temperatures below 50 degrees, which cases where the cool season grasses grow is easy.
Yeah.
So I don't know what that number is, and if we even do know it for sure. Induction, typically it's the photoperiod response or the length of day. Cool season grasses are long day plants. They only flower after exposure to day lengths greater than a critical number of hours, and warm season grasses are short day plants. Now, why would that be? Can you think? One of the things here, the plant comes out in the spring, and when cool season grass first comes out in the spring, and it's the temperatures are warming up. Those initial few weeks, there can still be risks of frost, right, and cold temperatures. So as the day length gets longer and it reaches that critical point, the plant has escaped the risk of some of those freezing temperatures that could cause damage to the seed heads that they're being produced. So it's basically allowed itself to reach a point in the growing season where it's going to have ideal conditions for growth and seed head production. and so it gets it, gets it in that window where it's going to have less stress and be able to do well. Warm season grasses are short day, so they look for days shorter than a critical number of hours. And so we see warm season grasses, if they start to throw seed heads, actually after the summer equinox, and we'll see it coming in the fall here. Sometimes it's triggered with high temperatures. Sometimes it's drought stress. I saw a really weird situation on Florida Field when Celebration was out there. There were seed heads on everything except where, if you guys either know or watch, the behind the teams on both sides of the field, there's a metal fence that separates the teams from the wall so that people can walk back behind them. And it just has a bar across the top and has poles coming down like that and a bar across the bottom. It's not a fancy fence. Looks nice, but it's not a fancy fence, right? The crazy thing about it was that where this top one on the east side of the stadium, sun comes up over the side of the stadium, where this cast the shadow on the field at about 9:30 or 10 o'clock in the morning, there were no seed heads. But the entire rest of the field had seed heads. Now, these didn't cause seed head production change, but if you think about it, the sun is coming up and moving across the horizon faster than it was going up. So it was a shadow was being cast by this top bar longer in any one place than what these were. But it was I can't explain it. I don't really know why, but it was as clear as day a response to that shadow being cast that caused a area in the field to not have any seed heads where the entire rest of the field was loaded. So, crazy things happen, but whether it can be light temperature, it can be any number of different things that cause it. Taxonomy of grasses. All the grasses are members of Gramineae or Poaceae. Less than 50 of those, more than 10,000 species are used as turf grass. Less than 50. When you even think about it, bamboo is a grass, corn's a grass, sorghum's a grass. There's a lot of different grasses. Some of them that we use for forage, some of them that we use for food production for us. Some of them are aesthetic value, but there's very few of them that actually are what we're able to use and maintain in turf grass systems. From a naming convention, I'm going to ask you and tell you the scientific names for the grasses. What is the importance of knowing the scientific name for a grass?
Identification. So you're able to communicate with people what it is.
Right, and more specifically, when does that become important? I mean, if we all in here, if I taught all of you in here that St. Augustine grass was, silly sour grass is the scientific name, right? And we all were talking to each other, that would be fine, right? Because we would all know what we were talking about. If someone said it was silly sour grass, oh, that's St. Augustine. But when we left this room, or we go to another state, or we go to another part of the country or the world, now we'd be like, well, what is it? So having that scientific name be something that's a naming convention that's consistent across all parts of science means that when we may be talking about zoysia grass, but I left it in your attention. When we talk about zoysia grass, it's also known as Japanese long grass. So in some parts of the country, you'll be like, well, we're using zoysia japonicas, which should be enough for them to understand, but they may know it as Japanese long grass. Or they may ask you if you've worked with Japanese long grass. Like, I don't know what you're talking about, because Dr. Cruz only talked to us about them as zoysia japonicas. I don't use Japanese long grass to talk about the coarser texture zoysias. I don't. I talk about them as the japonicas and the machoas. And so that really is, it's about communication, being able to communicate consistently amongst everyone who might have any number of different common names, right? So subspecies of plants, can differ. We see the SPP designation. That's a species that has some smaller, different characteristics that might be found in different populations or geographic locations. What we will talk about probably more than anything is varieties or cultivars. And in turfgrass, we talk about a lot of different cultivars, cultivar names, which is a cultivated variety. These are a species of grass, could be Bermuda grass, Synodon dacron, cross with Synodon transvolensis. It's a hybrid Bermuda grass, which, from a genetic standpoint, should all be the same, but because it has some small different characteristic, whether it's the leaf texture, could be the growth rate, it could be genetic color, we've identified it as having unique characteristics compared to everything else, propagated it to give us enough to plant out in large quantities, and named it so that we can claim some, unique identity to it and try to make money off of it in many cases, right? And the cultivars are sold for the characteristics that the breeders have been able to identify or to create in those grasses, and then that allows them to gain popularity and notoriety and make money, which is what everybody's trying to do in one way or another. Or for the end user, what's the important part? Name of the cultivar is probably not important, right? What is important to the end user?
How it looks.
It's these small characteristics that make it different, right? Could be the looks, could be the disease resistance,
Actually, like some cultivars need like lower, higher.
right? It could be maintenance requirements, absolutely. So, you can look at this whole naming convention and how grasses are marketed from two different angles. There's one angle that's making money, and that's what's driving it, so they can have something that they can sell. But ultimately, for the end user, there's also the benefit of being able to know that that grass is known for these characteristics, and that's something that's going to maybe give me an advantage in taking care of my little piece of property that I'm trying to get some sort of production or use out of. The Festicodiae are the cool season grasses, really found mostly in temperate regions of the world. They have C3 carbon fixation. Now, you think back to photosynthesis in your biology class or botany class at some point. We have C3 and C4 plants within the grasses, within plants. C3 carbon fixation happens through the Calvin cycle. There's about 391 species, and they make up about 36% of the grasses in North America. Panacoideae are the grasses that arrive from tropical and subtropical regions that are warm season grasses that have C4 carbon fixation. The carbon fixation in those, which is the slack pathway, happens in the bundle sheath cells of the plant, which protects them from some of the oxidation that can occur outside of that and makes it a more efficient system under higher temperatures. They're about 33% of the grasses in North America. And ergo, I wouldn't even know to say that. Sound it out. Adapted to semi-arid regions. Again, they're C4, about 28% of the grasses. So that, from there, any questions about that before I go and find? Any questions?
C4 plants, they tend to open this high at night. Otherwise,
Yeah, the respiration happens at night. So now, any questions about anything? You guys on Zoom, you can still see everything okay?
Totally.
Yes.
Excellent. Are you guys still awake? I'm keeping these guys awake because I stare at them in the
Yes.
eyes.
We're awake.
They're scared to fall asleep here. I would never do this, but I did have, that just made me think of, I think it was in junior, senior in high school, where I grew up in a small town. My entire graduating class was 33 students. For all of you, that probably sounds maybe not crazy for everybody, but usually that's like a tenth or less of Minnie's graduating class, 300 or 400 at least, and maybe up to 1,200. But I was in a class that there was only like 15 or 18 of us in the classroom, and one of the kids fell asleep. The teacher grabbed one of the erasers, dinged him on the head. He didn't stay asleep very much longer after that. Things that you could get away with that I could never even think about getting away with or trying now, but
Oh, yeah, you get arrested.
yeah. So you guys are all safe. I mean, it doesn't matter how many erasers I have up here. I'll just let you sleep. I like my job and I like going home today. I'm not going to test you on photosynthesis at all. Don't feel like you have to memorize this. This is here for your reference and use. What I do want you to know about photosynthesis within the grand scheme of the grasses is that we have C3 and C4 grasses that are typically referred to as a group as which? I'm going to not refer to them as C3 and C4. How might I otherwise refer to them? Warm and cool season. So C3 being cool season grasses, C4 being warm season grasses, okay? Know that the warm season grasses have the C4 carbon pathway, that's unique to them, and the C3 grasses have the Calvin cycle 3 carbon pathway. Might be good to know that, photosynthesis takes carbon dioxide and water, you add some sunlight, you get some carbohydrates out of it. That's about, I'm not even gonna test you at this level. But everything that we talk about with managing turf grasses depends heavily on this process, okay? A lot of this is gonna happen, go study it somewhere else. I'm not one to teach you this. But the things we talk about from a management standpoint, mowing, fertilization, diseases that impact the canopy, all these shade, hours of sunlight, fall versus spring with the angle of sunlight that impacts the amount of sunlight that it receives, impact photosynthesis, and that impacts the plant's growth potential and ability to handle stress and recover and things like that. So when we look at what's happening with the turfgrass system and really any plant, part of it we talked about that I think people overlook a lot is the health of the root system. And then the next part is where are we at with sunlight? Because these are two things that we don't have a heck of a lot of control over easily. We don't, we get as much sunlight as we're allowed to have, depending on weather conditions or where we're at geographically, right? Florida is referred to as the sunshine state. You think Florida gets about as much sun as, for instance, Arizona, New Mexico? We get more? More or less than New Mexico, Arizona? Less, significantly less. Florida gets significantly less than the desert Southwest because of the weather patterns, because of the fact that we have cloud cover almost daily. Not for the entire day, right? But we have cloud cover almost daily that impacts the amount of sun that we get. Take that out of the equation, the fact that we have more humidity actually reduces some of, we get some of that haze in the air that actually reduces some of the solar radiation that we can get versus the more dry climate where there isn't as much reflected off of that humidity in the air. So we have, when we look at we've done some research looking at what's called the daily light interval requirement, the amount of light that a plant requires to meet its needs and produce a healthy plant. And Florida is actually, for being a sunshine state, from a marketing standpoint, in the best case scenario, no trees, no shade, full sun exposure, we get basically borderline amounts of sun for warm season grass around. So anything that happens that tree shade, building shade, something like that, those grasses are already right on the threshold, and it doesn't take much to drop them below to have them start to decline, because we don't have any excess room. We're not dealing in this situation with luxury consumption, if you will. So because I'm not going to test you on this, it's here for, and I will post these slides on Canvas as well, so you guys can go through and look at it and refresh your memory if you'd like. Temperature requirements. This is what I do want to talk about. C4 grasses are adapted to high heat, drought, and humidity. Examples being the Bermuda grass, zoysia grass, seashore paspalum, centipede, carpet, all those. Respiration increases as temperature and light intensity increases. So the photosynthetic process becomes more efficient and more productive as temperature and light increases. C3 grasses are adapted to cool temperatures, mild drought and humidity. As temperature increases, the competitive edge goes to the warm season grasses. Now think back to that. The pictures that I showed on Wednesday, where we had the warm season and cool season grasses over the steam tunnel. The middle of the summer, that warm season grass had the advantage, and the cool season grass actually got to the point where between either drought stress or heat stress, it went dormant. Right? But the warm season grass, even though it's under a steam tunnel, didn't get to the point where it's stressed enough to go dormant. C4 grasses have a linear increase in photosynthesis as light levels increase. This can help. C3 grasses can reach a saturation point in their photosynthetic process where photosynthesis peaks and falls off. And I'll show you that in a graphical form here in a little bit. C4 grasses are more competitive during drought or high humidity conditions. What is the challenge about high humidity conditions for grasses? What comes with humidity?
The lack of transpiration.
Lack of transpiration, so we see a reduction in transpiration. What else do we get with humid conditions? Disease pressure. Side by side, warm season grasses are more tolerant to fungal diseases and will not suffer from the same fungal diseases as quickly as cool season grasses. Cool season grasses tend to be more succulent leaf tissue. They're not as hard, basically. They're more difficult for fungal pathogens to break to infect. So as we get into higher heat and humidity conditions, we can have them growing in the exact same situation. Cool season grass will be susceptible to disease long before warm season grass will. C3 grasses are very sensitive to drought and hot climates. This is the temperature range. I was off a little bit. So the optimum range, when I mentioned it before, for cool season grasses is 60 to 75 degrees. Doesn't mean they can't grow outside of that. With cool season grasses, they will stay green even under frost and snow. So the only time you really will see a cool season grass go dormant, where it starts to turn brown, would be either under drought stress. Actually, really, it's primarily drought stress or heat stress. Only when it gets too hot or too dry will they turn brown and go dormant. Cold doesn't make the cool season grasses go dormant and turn brown. They will slow down. Their physiological processes will slow down. They will slow down growing, but they stay green. As soon as the air temperature gets above 32 degrees, above freezing, photosynthesis will start back up in those plants. So they don't go dormant in the winter. And that is something that we actually will use with, when we talk about establishment, the fact that the best time to establish a full season grass is actually in the fall, if you're going to do it by seed. Because if it starts germinating in the fall and you get it planted before the soil is too cold for it to grow, not only do you get the entire fall whenever temperatures are above 32 degrees to see you later. Yep. Not only will you get that entire fall when the temperatures are above 32 degrees for it to grow, it goes into winter, everything stops for a little while, and then next spring, you have the entire, anytime the daytime temperature is above 32 degrees, that grass is growing again. Where to get a seed to germinate, you'd have to wait until soil temperatures are above 55 degrees. So there's a huge window there where the grass can be growing in the spring before you'd ever be able to plant by seed and have it germinate. Warm season grasses ideal range is 80 to 95 degrees. This is our sort of range of adaptation. Let me look at this here. So these are two different ways of looking at it. I prefer this second one. We've got cool, humid, cool air. And then over in the Pacific Northwest, cool, humid again when you get on the other side of the mountain range into like Portland and Seattle and that area, right? It's really wet along this coast. As soon as you go through that mountain range, desert, basically. Cute little town right down here called Hagerman, that's where I grew up. Then we got warm and arid down here in the southwest, warm and humid down here, cool and humid up here. And then we got this beautiful orange area in the middle of the country called the transition zone. I mentioned, I think, the transition zone a little bit, either Monday or Wednesday. This part of the country, from a climatic standpoint, is too cold for warm season grasses to do really well, and too warm for the cool season grasses to do well. So we end up in this part of the United States with a hodgepodge of everything. Some people growing warm season grasses, some people growing cool season grasses. The people that are growing cool season grasses, because it's warmer, have more disease pressure. You have to water them more to keep them from going dormant. The people that are growing cool, warm season grasses, we got this cooler temperature, right? And think back to what I talked to you about, like the person in Wisconsin that came up and told me he was trying to fix his neighbor's yard and it was brown for most of the year. Yeah, what happens here is if you've planted your golf course, your home lawn to a warm season grass, there's a lot of zoysia grass used in this part of the United States. It will be brown for weeks before it goes green, while everyone else that has a cool season grass will already be green and growing. So that is a challenge there. So we're basically at the end of the class period. What we'll do on Monday is we're going to go through, starting with the warm season grasses, some of the basic characteristics of each of the general species of grasses, starting with Bermuda grass, and then we'll go into the cool season grasses and talk about them. I'll try to probably bring in a couple examples to look at, but that's what we'll do. Any questions about anything?
Have you published the canvas?
No, I have not published a canvas yet. I ran into some things yesterday that took up a bunch more time. And so yeah, it is not. I will. Well, the only thing that will be due from this week sort of is this sort of intro quiz, and I'll make sure the deadline on that's not a problem.
Okay.
All right.
All right.
I'll make sure I'll get the slides posted up there for you. They'll be actually